Betul.
Yep.
Alright, dah record.
Okay. Okay, thank you for reminding me. So we have variations in free fall. Sometimes we start our initial position and our final position is the same. So I have a ball, I throw it upwards, it goes up, and then it stops momentarily, V equals to 0, and then it goes down, and it lands back on my hand. Ataupun it lands back on the ground. If I started from ground, tak tahu lah macam mana nak baling dari ground kan. Tapi if it started from X equals to 0, and therefore it lands back at X equals to 0. Sorry, it's Y equals to 0. Okay, sebab Y exists kan. Y equals to 0, ni atas, ni atas. Let's say this is Y equals to 10. At the maximum height, we know that V equals to 0, and going down, blah, 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 and then it goes back to Y equals to 0. And the nice thing about free fall is that we know that at the maximum height, the V is equal to 0. This is for all variations. Doesn't matter if you have the same starting point, if you have a different starting point, like this guy over here, your V at the maximum height will always be 0. Your V at the maximum height will always be 0 because when you go upwards, your V is positive. When you go downwards, your V is negative. Okay? And the time for a symmetrical motion, like this guy, the free fall over here, for a symmetrical motion, you know that time to reach the maximum height will be equal to the time from the maximum height down to the final position. So T1 is equal to T2. Oops. I would say, I'll just say T and T lah. No, T1 and T2. So T1 and T2, V1, V2. T1 is equal to T2 dari segi value. Time is a scalar quantity, so you don't have the positive and the negative. V1 is equal to V2, but the directions are different. Going up is always positive, going down is negative. What about the displacement? What can we say about the displacement? If motion going up, what is the displacement? Tak ingat dah? Oh, I have, banyak check kat sini. Didn't notice. Tak ada pun orang tanya. Tak ada pun orang tanya, tak ada pun orang jawab. So what can we say about the displacement for motion going up and motion going down?
Positive for going up and negative for going down.
Positive for going up and negative for going down. Okay, let me write that first. Positive S, negative S. We call displacement for projectile motions and also for free fall as S. Why is it positive and why is it negative? We talked about this from last class. Why is it positive and why is it negative?
Final, yang akhir tolak mula.
Akhir tolak initial. Okay. So S is actually delta X or delta Y in this case because kita naik Y axis, right? So S is equal to delta Y, and we know that anything that has delta means the change, and the change always refers to final minus initial. And if we divide this into two sections, our Y final is 10 and our Y initial is 0. Okay, so we get a positive value. So our S is a positive. But if I'm going down, my initial point, warna hitam tak nampak apa. My initial point is over here and my final is here. So my initial is 10. So S equals to delta Y, Y final minus Y initial. This is S2, this is S1. Y final is 0. And my Y initial, I started from here, it's a 10. So now my S becomes a negative. Okay, so this is how you can make sense of why the motion is positive and why the motion is negative. Selalunya macam tu lah. Okay, so that is the displacement. So positive S, positive V, naik atas sekali at maximum height, V equals to 0. Going down, negative V, negative S. And the time is a scalar quantity, so it doesn't have any directions. T1 is equal to T2 if the motion is symmetrical, meaning to say this part and this part is identical, then you can say they are equal. For this situation where this section is not equal to this section, then you can't say V1, the V over here, the V on the left is the same as the V on the right. You can't say that. So kena pakai equation lah. Equation apa? Linear kinematics. Okay, so this is like a general guideline, general. So V is always equal to 0 at the maximum, positive, and then your acceleration is always going down because it's due to gravity. Even though you're going up, gravity is going down. Even though you're going down, gravity is still going down. You're going down, the gravity does not automatically change to upwards. No, the gravity is still going down. So your acceleration is always negative. Okay, saya dah menyanyi dah. Kalau tak ingat juga, Okay, so acceleration is always negative and it is equal to G. What is G? 9.81. Bolehkah kita bundarkan kepada 10? Buat masa ni belum lagi. Okay, untuk physics punya, for physics asasi kita tak pakai 10, kita pakai 9.81. Okay. And also in web assign. Alright, so that was your recap. And then we did this example already. A ball is a ball. Dah tahu jawapan dia semua. Kita dah discuss last time. Ini pun, ini dah. Baling bola daripada atas turun ke bawah. We already did that as well. Okay, so now we go into projectile motion. Projectile motion. So what is the difference between projectile motion and free fall? So when we talk about free fall, we are only dealing with the y-axis. When we talk about displacement, it was at here to here, and then from here to here. So it was only dealing with one axis, going up and going down. There's no x component to the free fall. We assume that if I throw the ball, it goes back down. And tak ada ke kanan, ke kiri, tak ada. It just goes up and goes down. That is free fall. But for projectile motion, you have that x component. Okay, and we have already learned in chapter 1, when we have a vector that has some angle to it. Okay, we have a vector. The vector is called r. This is a position vector, delta r. This vector has some angle to it, theta. How do I know it has an angle? I'm talking with respect to the x-axis. Macam biasalah. This is the x-axis. And with respect to the x-axis, it has some theta. It has some angle. The angle can be anything, 30 degrees, 40 degrees, 50, whatever, asalkan less than 90 lah. So this vector has some angle with respect to the x-axis. So I immediately know that I can actually resolve this into its x and y components, right? This is my x component and this is my y component. Remember, your vector is always sandwiched in between its components. Your vector is always sandwiched in between its components. And Rx, the component x and the component y of r vector is going to give you r vector. Okay, so yang ni, when you resolve it, you get these two guys. When you add them together, you get r. So it's interchangeable. Jangan pandai-pandai tukar jadi z pula bila rx plus ry tiba-tiba dapat z. It's a different vector. So no, so r you get, from r you get x and y components. From the x and y components, you get the r balik. So it doesn't go anywhere. Okay. Okay, so we already know this part. So now we apply it in projectile motion. Kita dah tahu pasal vector about this one. Oh, don't delete this. Now we apply it in projectile motion. So if Haikal is here, okay, Haikal dengan Shakila, okay. Haikal warna pink sorry Haikal. So Shaki is blue. Terbalik tapi tak apa. Tak siapa cakap color refers to a certain gender, right? So Haikal is the pink guy. So he moves up here, goes down here. And then I asked the class, hey, what is Haikal's position at this point? What is Haikal's position at this point in terms of X and Y? Of X and Y. Ni soalan saya kepada kelas. haikal punya position in terms of X and Y. And then I tell Shaky, boleh tak? How long do you have to walk? How long do you have to walk in the X-axis? And how long do you have to walk in the Y-axis to reach the same position as haikal? Bukan how long, how far, sorry. How far do you have to go in the X direction and in the Y direction to reach the position, to reach haikal's position lah basically. Jumpa balik lah. Tadi dah berpecah, berjumpa balik. Korang jumpa lah balik classmate kan. So I'm asking Shaky, how far does she have to walk to reach haikal? So sebenarnya Shaky punya perjalanan dari segi X dengan Y ni adalah komponen kepada perjalanan haikal kat sini. Haikal punya perjalanan ke sini. I don't know why this is funny, sorry. Okay, so whenever haikal stops at a position, sebenarnya Shaky boleh pergi ke tempat haikal dengan cara naik X dengan Y. Haikal ni dia special case, kita lonjak dia. Kita ada kita ada mesin kan, kita mesin. Lepas tu kita baling dia into a projectile motion. And then kita ambil video, lepas tu kita pause. Tengok, oh haikal kat sini. Okay Shaky, macam mana Shaky nak pergi ke haikal? Berapa X, berapa Y? Macam tu lah. So that is how projectile motion ni kita akan break down. So projectile motion ni haikal, kita break down dia dalam bentuk apa yang Shaky kena jalan ni. So kita akan break down projectile motion in the X and in the Y. Walaupun rupa dia macam parabolic curve, but kita boleh break it down dengan cara Shaky jalan ke X dengan Shaky jalan ke Y. What if I take the video, I rewind it and I want to know what is haikal's position over here? Boleh juga, I can still break it into X and Y. I can still ask Shaky to go to haikal's position. Shaky, macam mana nak pergi ke haikal kat sini So Shaky said, oh senang je. You have to go this much in the X and you have to go this much in the Y. Okay, at any position you can do that. You can break it down into the X and in the Y position. Sebab projectile motion ni is a vector juga. It's a vector and you can break it down into its component. And since it is two-dimensional, you will have X and Y. Tadi free fall, it was one-dimensional, going up and going down. So we didn't have the X. So we just say, okay, it's just S, right? But in projectile motion, we have the X and the Y. Okay, harap clear. Projectile motion dengan free fall, perbezaan dia adalah ada projectile motion ada 2 dimensi, free fall 1. Okay. Oh banyaknya chat, kejap. Kesan haikal breakdown. Ada soalan ke? Tak ada Doktor ada budak baru. Sebab itulah saya kasih email semua tu. Saya tahu. Okay. Okay, is everyone clear on the difference between projectile motion and free fall? Buat masa ni secara konsep dulu. Okay ke? Okay. So tak ada soalan Alright, so I'm moving on. Okay, tadi tu kita merepek sikit. Now kita go into the equations. So acceleration of a projectile motion. For any motion, we will have acceleration, velocity, and also displacement. So kita akan guna linear kinematics to solve for the projectile motion. But this time, we are talking in 2 dimension. Previously, we only dealt the motion in terms of 1 dimension. Okay, so when I talk about projectile motion, there will always be negative acceleration at anywhere of the motion. I have a ball, I throw it in projectile motion. Macam mana nak buat projectile motion? You have to aim the ball at an angle. As you can see over here, there is an angle. So bila kita nak main basketball pun kita tolak at an angle, right? So you get that projectile motion. So samalah, kita kena ada some angle for the projectile motion to happen. If you baling ke atas, then there's no angle. It's just like 90 degrees, right? So 90 degrees up and then it goes down. But if you put it at some angle that is below 90 degrees, this angle is less than 90, then you will get a projectile motion. Okay, so the projectile motion, the acceleration in a projectile motion, the x component is always 0. The x component is always 0 and the y component is always negative g, which is your gravity. So you don't have an acceleration going to the right or going to the left. It's just going downwards, which is due to gravity. Tak ada ke kanan, tak ada ke kiri. It's just due to gravity. Therefore, the x component, the acceleration in the x direction is equal to 0. This is very, very important. Please take note. The acceleration in the x is equal to 0. The acceleration in the y is minus g. So this is the first thing that you have to remember about projectile motion, apart from it being 2D. Okay, so we have the x, right? This is the x and this is the y. We're already breaking it down into 2 dimensions. Okay, and then we talk about the velocity of the projectile motion. So when I launch my basketball, right, I push it and it has some velocity. It has some velocity. So again, the acceleration is 0 and the acceleration in the y is minus g. So my initial velocity is v naught. Okay, this is my v naught, my velocity vector. So if I want to know the x component of this vector, I have to resolve it. So it becomes Vx equals to V naught cosine theta. Why does Vx have a cosine instead of a sine? Why does Vx have a cosine instead of a sine? Anyone? Come on, come on. Oh, ada orang jawab kat chat, hopefully. Sebab terbalik. Bukan sebab terbalik. Remember, what is the condition for an equation to get the cosine?
Same direction.
Like, kuat sikit tak dengar? The angle must be, okay, I have a chat here. It must lay on the x-axis. Amy jawab adjacent to the hypotenuse. Adjacent to the hypotenuse. Okay, betul jugalah. So Afika said lay on the x-axis. Betul. So the angle must be touching the x-axis for this guy to get a cosine. Okay, I'm going to repeat myself sebab nampaknya ramai yang tak ingat. The angle must be touching the x-axis for my x component to get a cosine. Okay, with that said, if my angle was not there, okay, abaikan angle ni and I put my angle over here, what would be my x component? Vx equals to V naught. What's the rest? Kelas ni pemalu betul. Tak nak guna mic.
Ada kan?
Sine. Okay, so V naught sine. Sine of what? What angle should I put here?
Sin theta.
Okay, so it's not 90 minus theta, but it's theta. So this component, okay, this x component gets a sine because this angle is over here. Now another way to write this is you can say V naught cosine 90 minus theta. Whatever the angle here is, it's 90 minus theta, right? So kita padam ni jap, 90 minus theta. So the angle that touches the x-axis is 90 minus theta. Let's say it's 75. Okay, so I can write here V naught cosine 75. But if I wanted to use 15, the angle 15 over here, it has to be a sine. Okay. Okay, ni saya ulang balik tau. Benda ni kita dah belajar. So I hope everyone is not confused by this. So let's use V naught cosine lah. Okay, so this is our Vx equals to V naught cosine theta. And therefore our Vy will be V naught. Our Vy will be V naught sine theta. Okay, the angle is touching the x component, therefore this guy gets the cosine. That's the condition that we talked about earlier. in chapter 1. Okay, so now that we know what is the Vx and the Vy, since this is my launching velocity, right? This is my launching velocity. I can see that this is my initial velocity. This is my initial velocity. Therefore, I can write this as Ux and Uy. Remember, U is equal to Vi and V is equal to V is equal to V final. This is for linear kinematics. This is the notation that we use, U and V. U is initial, V is final. So because we know that this is initial, I would say this is Ux, V naught cosine theta, Uy, V naught sine theta. So this is what I'm writing here. Acceleration, X and Y, check. Initial velocity, Ux, Uy, check. So we already know the velocity and acceleration, provided that we know the angle and provided that we know what is the launching velocity. Okay, velocity yang kita tolak basketball tu. Alright, and then the final velocity, okay, this is something tricky, a little bit tricky. So if you observe this table, the final velocity is actually equal to the Vx. Whereas the final velocity in the y component, you have a minus gt. Okay, a minus gt. Why doesn't, okay, my question is, why doesn't the velocity in the x component change? Kita dah sampai kat sini. But the velocity in the x direction does not change. Anyone wants to guess why?
Constant velocity.
Apa dia lagi sekali? Because acceleration is zero. Correct, Ian? Yes, because acceleration. Yes, Ian pun. This is new students, eh? Korang yang lama ni bila nak jawab soalan saya betul-betul. Okay, thank you, Ian and Ian. Amy, because kita assume tak ada friction. Betul juga. Betul juga. Okay, but the accurate answer to this one is because acceleration in the x component is zero. So, remember that we have this equation V equals to U plus AT. So if we wanted, this is final, this is initial. If our acceleration is zero, right? Vx equals to Ux plus acceleration Ax, T. Ax is already zero, so this cancels out. Vx is equal to Ux. This is why the final velocity does not change with respect to the initial velocity. You get the same value, okay? Whereas for the y component, your Uy, we initially started with the V naught sine theta. The final, kita pakai balik equation ni, the linear kinematic equation, but we use it for our y component, Vy, Uy plus minus g, because this is our Ay, minus g, t. Okay, so you would get something that changes lah. It becomes less. Okay, your Uy is some value minus with acceleration times time. So you get something less from the initial. Okay, and then time interval is a scalar quantity, so there's no x and y component. It's just t. Okay, time is a scalar quantity. There's no x and y components. It's just t. Okay. Ada orang pernah tanya saya kenapa t tak ada ty dengan tx. Memang tak ada. It's a scalar quantity. Okay. Okay, so this is for vertical motion. Dia tulis kat sini, Vy equals to V naught sine theta, which is what we have here. Over here, V naught sine theta plus minus gt. Okay, g is from the acceleration, and then we have the time. Okay, so this is our velocity. Okay. The velocity at any point, okay, look at this part. The velocity at any point is the vector sum of the two components. So let's say you wanted to solve, you wanted to solve for this point lah. You wanted to solve for this point, let me make it bigger. You wanted to solve for that point, and you know that when you try to solve it, you get that the Vx and the Vy at this point is some value. Let's say Vx is 10 and the Vy is 12. And they are asking you, okay, at this point, at position x equals to 5 and position y equals to 15, what is the velocity of the ball? So from your calculation, let's say kita dah tahu, kita dah buat calculation and we get 10 and we get a 12 for our v. So we use the Pythagoras theorem that we learned earlier untuk dapatkan the magnitude of our velocity. Okay, by vx squared plus vy squared, square root the whole thing, you get the magnitude. In terms of direction, kita tanya tak macam tu they can ask you the direction, so you just use the inverse tangent lah. Tangent theta vy over vx, or theta equals to inverse tangent vy over vx, and you will get the angle with respect to the x-axis. Okay, so this is your imaginary x-axis. So this is your angle. So you would get it if you use this equation. So vy over vx, or theta equals to inverse tangent vy over vx. Always y is on the top, x is on the bottom for anything. If you're talking about acceleration, then ay over ax is velocity vy over vx, and displacement sy over sx. Okay, then you will get the angle. Okay, nanti kita akan buat example. This seems like lengthy, I know. Okay, so and then we already talked about acceleration. We already talked about initial velocity and then final velocity. Remember that we talked about free fall. When we have free fall, at the maximum height, the v is equal to 0, right? It's the same case over here, where v is equal to 0 over here. My question is, which v is 0? Is it vx or is it vy? Is it vx or is it vy that is equal to 0 in this case?
Vy.
Vy. Kenapa? Ramai yang jawab. Okay, so vy. Okay. Betul vy, but why? But why? So vy, kita padam balik. So it's vy equals to 0. So why is it vy, not vx? Why is it vy and why is it not vx? Try je, salah tak apa, as always. Sebab dia tak ke atas lagi. Betul? Betul, Amy punya jawapan selalu out of the box. Saya macam terkesima selalu. Because there is deceleration in y component. Okay, Vikram is answering because there is deceleration. Because acceleration is against y velocity. Okay, betul. Ian betul, Vikram pun betul. Deceleration negative E, betul. Betul. Okay, so the answer is, remember I told you that Vx, your Vx is the same daripada awal sampai akhir because there is no acceleration in the x. Which means that the velocity is going to be constant je. So, kat sini dia sama Vx value dia, kat sini pun value dia sama, 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 kat sini pun value dia sama. The Vx component doesn't change because kita assume tak ada air resistance in our problems, in our physics problem, kita selalu assume neglect air resistance. So our Ux ataupun our Vx is the same at all points. And acceleration only acts in the y-axis. So as you can see here, kita naik and then kita turun. Tapi kita punya x component selalu ke kanan je. So ke kanan je positive x, right? Positive x ataupun just constant Vx value lah. Constant Vx. There's no change in signs and we know that the magnitude doesn't change too. Constant V to the right. Whereas for Vy, it goes up and then it goes down. So you have the positive component here and the negative component here. Positive, 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 and then stop, turun, negative, negative, negative. Dia tak adalah stop lama, dia macam momentarily or instantaneous punya equal to 0 tu sekejap je, macam split second. So naik, become 0, negative. Sama macam free fall tadi, V positive, going upwards, V equals to negative. V equals to 0 and then V negative. Sama, kat sini positif, negative. Kat sini semua y. We didn't talk about x. In this case, we have the x, but the x is going to the right and is constant. Okay, so that is a very important fact that you need to know for our physics problem relating to projectile motion. Constant v in the x direction. Constant vx in, constant vx lah. Okay, vy dia berubah-ubah. Okay, what else? Okay, we have the time interval. Kita akan solve pakai linear kinematic nanti. And then displacement, we have x and y displacement. Like I told you before, we can, when we have like two different accelerations or two different velocities, we can split the motion into two. So this is my first part and this is my second part. Sama macam kita jalan in one dimensional. This is Vikram walking. Vikram cakap penat lah nak patah balik. So dia patah balik daripada sini ke sini. So kita boleh bahagikan this one as number 1 and this motion dia patah balik tu as motion number 2. We can split it because displacement dia berubah. Sama kat sini kita punya signs ada perubahan from positive to negative in our velocity. So we can divide it to make our life easier. And we know that the final velocity for section 1 is 0. And this is equal to the initial uy for section 2. Nanti kita akan go over an example. If this confuses you, bear with me dulu. Kita akan buat example nanti. Okay. So why am I trying to relate back to the one dimensional and why am I trying to relate back to the free fall? Sebab I don't want you guys to panic looking at the two dimensional. Sebenarnya it's almost like one dimensional. You just have to break it down to make it look like one dimensional. I don't know if that makes sense. But tak apa, nanti kita buat example. Okay, so displacement, you have displacement in the x, which is what we talked about shaky just now. Shaky kena jalan x banyak mana, shaky kena jalan y banyak mana. So that is displacement. Okay, to reach the same position vector as Haikal. Okay, so you use linear kinematics as well. Let's try to do an example. Okay, so the shape of the projectile motion is actually a parabola and a parabolic equation is quadratic. So you have the to the power of 2, then you have the to the power of 1, then you have the to the power of 0, which is a constant. Okay, so when you have these, is this necessary to know? Not really, tapi if you're interested, you can know about it. This is when we try to rearrange the equation daripada mana tadi? Okay, kita tengok sini S equals to ut plus 1 over 2 at squared. This is linear kinematic punya equation. And in this case for y, our S is y displacement. Our u for our y is v naught sine theta. So this is what they are trying to substitute here. And for the t, diorang solve kat tempat lain. This is the t kat tempat lain and diorang solve. 1 over 2, 1 over 2. And a is minus t because it's acceleration going downwards due to gravity and time. Sama juga dia solve kat tempat lain and then they plug in over here. Okay, so rearranging this equation, dia dah multiply and dia nak rearrange. So you have the negative component here and you have sine and cosine gives you a tangent theta, that's it. And then this cancels out. This gives you a tangent and you're left with x tangent minus gx to v naught squared cosine squared. You know the drill lah. Diorang dah multiply everything and you get this equation. And this looks like a quadratic equation. You have the square, you have x to the 1, and you have, I think this is the constant here, displacement. And this is the constant. There's no x here. So x is to the power of 0. X to the power of 0, 1, x to the power of 2. X to the power of 0 is just 1, right? So you get the constant there. There's no x. Okay, so this, it's just saying that the displacement of this projectile motion is similar to a parabolic equation that we can describe mathematically like this. Is it important to know in this course? No, not really. But if you're interested, this is something you can explore later on for your mini project. Boleh cakap pasal ni. And also, if you're interested to pursue physics nanti, you can go and play around this one as well. Okay. All right, so we talked about acceleration. Kita dah cakap pasal initial velocity. Final velocity, we know that x is constant at all points, even though kita naik, kita turun, but it doesn't concern the x, so it's just the same magnitude, and it's going to the right. And our y changes, positive, negative. At the maximum height, it is equal to v equals to 0. Okay, so at the maximum height, we know that v is equal to 0. So kat sini, dia pecahkan this projectile motion into two parts. Dia pecahkan So this is the first part and this is the second part. Okay, so at the maximum height, to solve for the maximum height, which is the displacement in the y, to solve for the maximum height, which is the displacement in the y, we need to make this as our final v. And this is our initial v. Okay, so our initial v is uy, v naught sine theta, whatever the angle that is. And then vy, kita tahu kita pakai, our vy is the final v over here, which is equal to 0. And then you solve using your equation, v squared equals to u squared plus 2as. This is the linear kinematic equation. Okay, so now your s is your h, the maximum height. Your a is still gravity, and your u is u, but this guy, your final velocity is equal to 0. Because why? You're breaking this motion into two parts, and you're saying, okay, at the maximum point over here, this is my final for the first section. This is my final velocity. And you know that the final velocity, the velocity at that point is equal to 0. So you use that information, v equals to 0, u is equal to v naught sine theta plus 2 minus g, and h. H is your maximum height. You can label it as h. Okay, to differentiate between the normal y displacement. Kalau normal y displacement, you just label it as y. But if it's the maximum height, you label it as h. Okay. Okay, I'm going to repeat myself. From this projectile motion, we divide it into two sections. And the first section is the section that we are trying to solve for the maximum height. And we know at the maximum height, the velocity is equal to 0. So therefore, we make this as our final velocity, and we plug it into our linear kinematic equation where v is equal to 0. Our u is our initial velocity, y component. It has to be the y component plus 2as. Our a is minus g. Okay. So what if I wanted to find out what is the x over here? Can I do that? I want to find out what is the x. I don't want to know what is the maximum height, but I want to know, hey, what is the x at this position? I mean, at this position, basically. What is the x displacement at the maximum height? I can do that as well. I use this equation lagi. So I can't use this equation. Kejap. It has to be a different equation. So but v squared equals to u squared, and this guy becomes 0. So it doesn't really tell me anything. What is the equation that I can use? So we have equation v equals to u plus at, right? So we can't use this for x because this is 0. So v equals to u. So it doesn't really solve anything. S equals to 1 over 2 u plus v times t. We don't know the time yet. And then we have this equation, which we can't use as well. What other equation do I have? I don't remember. Let me see. Okay, it's this one. So you have v equals to u plus at, tak boleh pakai. This one, we don't know the time. This one, we need to know the time. This becomes 0 because acceleration is 0. This becomes 0. We need to know the time. And this one, we can't use this one as well. So basically, if you want to know the displacement in the x, we have to know what is the time. Because according to this equation and according to this equation, the displacement in the x is 1 over 2 u plus v times t. So the t has to be there. U is, you know that what u is. V is equal to u. This guy is equal at x, right? This one, u, we know the value of ux. We still need to know what is t. So kena tahu time. So you have to solve for time first, however that is. I have a question here. Tapi doktor, t bukan x. T bukan... kejap eh. Tapi doktor, t bukan x over v not. Oh, okay. Yang tu dia derive from somewhere. I wouldn't recommend you to memorize it like that. Sekejap, ada dalam, betul, Amy punya statement tu betul, ada dalam slide tadi. Sekejap, let me show you which one is Amy talking about. It's not this one. Okay, so yang T yang kat sini kan. X over V naught cosine theta. Yang ni datang daripada linear kinematic juga tau. Which one is it? V equals to U plus 80 bukan. It's S equals to UT. Where U is, S is X, U is V naught cosine theta, and then there's T. So basically it's just linear kinematic. Tapi kita still kena tahu T apa. So it's X over V naught cosine theta. This is where they got UT plus 1 over 2 80 squared. Okay, this one goes to 0. So this is where they got the equation for T. I wouldn't recommend you to memorize. Please try to find out using a normal approach of linear kinematics. Dia akan bagi all these values. So you can plug it in your linear kinematics and solve for the parameters lah. Okay. Soalan dia akan membantu lah untuk jawab T dulu ke, nak jawab S dulu ke. Okay, don't memorize. Please don't memorize. Only memorize the 4 equations that I showed you before. Only that 4. Don't have to memorize this guy. Please don't memorize. Okay, sebab dia tak boleh apply untuk semua condition. Okay. So let's try an example. We talked about the theory. Okay, and again, dibagi equation macam ni, I don't suggest you to memorize. Please use the 4 equations that we already know on linear kinematics. This is simply derivation, and sometimes you can use this equation wrongly. So it's better for you to use the 4 equations only. Okay, at the maximum height, we know this V is equal to 0. So you have to make this as your final V. Kalau kita nak cari range, we have to, I need to show an example. Okay, let's do an example. Range and height of projectile motion. Okay, so as you can see here, if your angle is small, you will get a smaller, you will get, patutnya further. So dia cakap kat sini, complementary values of initial angle result in the same range. Okay, what does complementary value mean? Complementary means theta 1 plus theta 2 will get you 90 degrees. So let's see, 75 and 15 gets me 90. So they have the same range. What does range mean? Range means the x displacement. R equals to range equals to x displacement. Is this important for you to know? No, but it can be a shortcut for you guys. Otherwise, just do the equations using linear kinematics. You don't have to memorize anything. Please don't memorize. Okay, 60. What is the complementary? 60 plus 30 will get me 90. 15 plus 75 will get me 90. So 60 is complementary with 30. So 60 dengan 30, dia punya range adalah sama. Itu je. This is the point of this slide. It's just showing you that they will have the same range. And then 45. 45 complementary dia, 45 juga. So dia tak ada kawan. So it's just there. 45 plus 45 equals to 90. And so on. Okay, the maximum range occurs at a projection angle of 45. So if you want to do a project and you want to get the maximum displacement, always aim for 45 degrees. Okay, assuming that all the velocities are equal. So V naught here, V naught here, V naught here, V naught here, V naught here. angle je yang berubah. So to get the maximum, your angle should be 45 to get the furthest x, to get the furthest displacement in the x direction. Okay. Okay, so let's try this together. Thank God there's some example. Try this. Let the launching angle and speed be 30 degrees and 50. So it's saying that we have a vector, okay, velocity. Walaupun dia cakap speed, but we have the angle and we have the magnitude of the speed. So therefore, it's a vector. Okay, this is 30 degrees with respect to the x-axis. And this is V naught equals to 50 meter per second. This is our first information. Find the time and height at the highest point. Find the time, it's asking for T, and H, capital H, because at the highest point. What is the technique to find this? What is the first thing that I need to remember to do this kind of problem? Remember, at height at the highest point. Apa yang saya kena ingat when I'm doing this? Hint, hint. What happens at the highest point?
0.
Apa yang zero?
V sama dengan
V.
0.
V equals to zero, correct. So you have your projectile motion and always your V is equal to 0 at the maximum height. So let's label that. V is equal to 0. What V is it? Is a Vy. That looks awful. Let me rewrite that. Vy equals to 0. And this is your initial, and this is what we're trying to find, H. This is what we're trying to find. This is H. Okay. So let's try to make a table of X and Y. Oops. Wrong. Kenapa ada biru ni? I don't like this biru. Sekejap. Sekejap. Home. Design. Mana dia punya table punya style ni? Sekejap Okay, finally. Kenapa tak ada yang kosong? Sekejap. I want a plain one. Okay. Tak ada lupa. This one. Okay, better. Okay, so this is our X. Let me draw this. This is for our X component. And this is for our Y component. Okay, so let's do it. So our velocity, our initial velocity, Ux. This is our initial velocity in the Y, Uy. What is my Ux in this case? Anyone wants to try? Come on guys, it's just resolving into vectors. Semua orang tak confident. Aduh. Oh, ada check kat sini. Sorry, saya tak perasan. V equals to 0. ME and oh, ni tadi. Okay. What is Ux? What is Ux in this case? 50 cosine 30. Okay, betul. Molly, good job. 50 cosine 30. Betul. It's just simple vector. What about Uy? Ni dah. X ni dah ada hint dah. What is Uy here?
T sin 30.
Yes, 50 sine 30. Okay, so immediately you already know what is your initial velocity because you have the angle and you have the vector. What is Vx? What is Vx? Remember I told you going forward the x velocity does not
50 cosine 30.
cosine 30. It's the same as Ux. Does not change. It's still Ux. What about Vy?
0.
0. Why are you saying it's 0? Why? This is not the final. Why are you saying is 0? Kena ada sebab, tak boleh suka-suka. Oh, ada 8 chat yang ni. Sebab dia stop. Dia tak stop. Kalau dia stop, kita punya bola tu tergantung kat tengah tu. Same. Oh, Ian jawab same. Okay. Oh, Felicia pun jawab juga. Sebab highest point. Yes, but our highest point does not necessarily mean the final point, right? So why do you say it's the final point in this case? How did you decide that it should be the final point? I can say my final is here too, but why did you choose over here? Kenapa? Nobody knows? Let me see, maximum point, because what we are concerned about is the maximum point, and that is where Vy is equal to 0. Okay, so my answer is, okay, betul, jawapan tu betul. My answer is that because when we want to find the maximum height, we need to break this into 2 sections. So for me to break this into 2 sections, this will be my final point. Okay, so oh, I did. Or is it me? Oh, it's not me. Okay. So in this case, your final is at the maximum height because you want to know the height at the maximum point. Remember, kalau soalan tu tanya pasal maximum height and you have a parabolic motion macam ni, you divide it into 2 sections whereby this point becomes your final. This is your first section, this is your second section. You divide it into 2 sections if they ask you for the height at the maximum point. Okay, so that is the tip here. If they ask you for the height at the maximum point, always divide your motion into 2 separate parts, and then at the maximum height ni V equals to 0. So that is your final V. Okay, so now that we know what is our V equals to 0, what about our acceleration? What is the acceleration in the X?
0.
0. And the acceleration in the Y?
Negative G.
Negative 9.81.
Negative 9.1.
0.81. Okay, great. So everyone knows about the acceleration. What equation should I use to solve for H? What equation should I use to solve for H? I have U, I have V, I have A. What is the equation that I should use to solve for H? Where H is displacement. So I have a chat here. Fourth equation. Can you tell me what the fourth equation is, Sophia? Sebab saya pun tak ingat sebenarnya.
V square equals to
Equals to U squared.
U square plus 2AS.
Okay, let's try it. So V in this case is 0. Kita cakap pasal Y. Y component. V equals to 0. Your U is 50 sine 30, whatever that value is. You need to square it. Don't just square the sine 30, square the whole thing. Plus 2 minus 9.81. Your S is your H. Your S is your H. Kenapa your S is your H? Because this is your final position. Therefore, this is your final displacement. Okay, dia kena tally. Dia kena tally. If you put your V over here, you put in the value of V over here, let's say it's minus 15, sebab dia ke bawah kan. You put a minus 15 over here, then your H is no longer there. It's going to be Y. It's a simple Y. It's no longer H. For you to use this equation and find H, dia punya V dengan dia punya H tu, dia kena tempat yang sama. So tempat yang sama kat sini adalah Vy equals to 0 and H. Baru boleh pakai equation ni. Kalau saya nak pakai equation ni dekat sini boleh, but now it becomes minus 15 squared, whatever position that is, Y. Boleh. But now we want to find out over here, right? So it becomes 0. Okay, kat sini dia bertembung 0 dengan H. Kena sama I cannot emphasize this enough. Kena sama. Tak boleh ambil V, tak boleh ambil H kat sini tapi ambil value V kat sini. Tak boleh. And then nak tahu kat sini punya H tapi ambil V kat sini. Tak boleh. Dia kena tempat yang sama. So you are finding height over here, right? The maximum height over here. Therefore, your V should be at the same point where you are finding the displacement. 0 and H. Okay, so this is a value and this is a value and this is a value. So we can easily solve for H, whatever that is. Let me use that. Let me use my calculator. So 50 sine 30. Your calculator should be in degrees mode. Don't use in radians. Squared. And then divided by 2 times 9.81. Okay, so I get H as, hopefully I'm doing this right. H equals to 31.86 meters. So that is the maximum height. Korang cuba tengok calculator dapat sama tak dengan saya? Saya ni tak yakin lah kalau pakai calculator ni. Okay, sama Okay, thank you. Okay, any questions about this part so far? Any questions at all? Faham kenapa V equals to 0 dengan H? Okay. Alright, so we found out what is the maximum height. Yay. So H equals to this equation, blah, 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 31.86 meter. Now it's asking, find the time at the highest point as well. Find the time at the highest point. Okay, so if I wanted to find the time, what is the equation that I should use here? Okay, what equation? Number 1, Shafika is saying number 1. Okay, number first. Okay, so Amy dengan Shafika juga first. Okay, let's try it. Number 1, V equals to U plus AT. Nampak sangat saya ingat number 1 je. Number 2, 3, 4 saya tak ingat. Okay, V is equal to 0. Kenapa kita pilih 0? Kenapa kita pilih 0 kat sini? Because kita nak cari time dekat the maximum height, which is where the V is equal to 0. Semua benda kena bertumpu kat tempat yang sama. Tak boleh seorang kat kiri, seorang kat kanan, tak boleh. You have to be at the same place. Your V and your final velocity, the time and the displacement should be at the same point. U memang tak boleh buat apalah. U initial kan. Final V, displacement, time should be at the same point. Do not selerakkan diorang. Kena sama point. So the point is here. This is the point that I'm interested to find the time. So U, whatever that is, kita nak buat dalam Y ke nak buat X ni? Okay. Y. Okay, boleh. Y, kita buat Y dengan buat X kan, kita buat dua-dua. Let's see. So this is Y. So kita boleh pakai 0 ni lah. U equals to 50 sine 30. And then plus minus 9.81 and T. Okay, so use my calculator. Please try to use your calculator as well because I don't trust myself with the calculator. 50 sine 30 divided by 9.81. So I get my time as 2.55. Dapat sama tak?
Sama.
Okay, thank you. Oh. Yeah. Don't be nice, okay, Mami have class. Okay, sorry, ada gangguan kecil. Okay, so the time is 2.55 at this point. Going from here to here, the time that it takes to reach the maximum height is 2.55. So can we do this in x-axis? Let's try it. Boleh ke tak? V equals to U plus AT. The A is 0. V equals to U doesn't really solve T. So tak boleh. Is there another approach? If we use, okay, tak boleh. Okay, so my other question is, what is the, oh, I think that is the next slide. Okay, yeah, it's the next slide. So abaikan. Okay, so you can't use the X. Always use the Y. if you are using V equals to 0 sebab V je, Vy je yang 0 kan. Kalau tak kena pakai Vx. Vx is just Ux. Doesn't really solve anything. And A is 0. So you can't use the X component to solve for this one. Okay, next one. Try this. Let's let the launching angle sama macam tadi. Find the time of flight. Okay. Time of flight, range, final velocity at landing point. So we started with this guy. So 50, and then this was 30, right? And then we found out what was H over here. And we know that Vy equals to 0 at this point. And then now it's asking you, find the time of flight. Tadi dia tanya time to get to the maximum point, which was over here. Now it's asking you the time of flight. Maksudnya the whole duration until it lands. The whole duration of the motion. So this is called capital T, or time of flight. Okay, I'm introducing capital T to you. It's called time of flight. What does it mean? Means the whole duration of time for the projectile motion untuk sampai ke landing point. Maksudnya terbang lah, jatuh. Okay, time of flight and then range. What is range? Range is the X displacement. Total lah, total X displacement. Total X displacement. Okay, sampai bila? Sampai dia terbang, sampai jatuh. And then final velocity at the landing point. So final velocity is this guy. Therefore, you need to know what is the Vx and what is the Vy at this point to find out what the V is. Okay, so time of flight is the total duration known as capital T. Range is the total X displacement. Berbeza dengan H tadi, the H is the maximum height. The maximum height. And R is the maximum X displacement. H is the maximum height, which is Y. Okay, this is max Y. Range is max X. Range is max X, okay? And range is obtained at time of flight. Sebab apa? Sebab dekat sini dia punya time is capital T, dia punya X is capital R, and the V is whatever lah, okay? The V is, we need to find it. Okay, so what is the information that we know so far from our previous example tadi? So we know that the time taken to reach the maximum point is 2.55 seconds, and the maximum height is 31.86. We can use this information sebab kita dah solve. This is part A, so you can use it to solve for part B. So let me copy this to the next slide. Time, I need to add another column here. Insert rows. Nak kerja macam tu. Sekejap give me a minute. Saya tak boleh nak copy. Baikkan sekejap. So I'm going to group this. It's already grouped. That's so weird. This is not working out. Okay. Let me just copy lah. Kita ada, I need to copy this. Sekejap. Copy. Kita akan pakai table yang sama because it's still the same problem. Okay. So let me add another column here. Rows below. Padam. The time is 2.55. Oh, this is not the actual time. This is time at the maximum height, 2.55 seconds. So now we are interested to find out what is our T and what is our R, where R is the X and T is just T lah. Okay, so from this T, can we say that capital T is basically 2T? Can we say that? Boleh tak?
Yes. Boleh.
Boleh sebab Cuma jawapan kena ada sebab. Saya akan tanya.
Symmetrical.
Because it's symmetrical. Yes, correct. So you have T here and then you reach the highest point and then dia jatuh. The time taken to jatuh is the same, provided that there is no anasi-anasi luar lah. So T and T kat sini, so you get 2T as capital T. So the total time to gerbang jatuh is equal to 2T. So that is equal to 2.55 times 2, 5.10 ke entah mana nak kira. 2.55 times 2, 5.1. 5.1 seconds. Okay, so with that said, I know what the time is, ataupun what is the time of flight. How do I find the range? How do I find the range? What equation should I use? I want to know what is R. Wait, oh, I check. Anasibah. Okay, which equation, guys? Equation 1. No, kita nak cari something with displacement, right? So displacement yang dalam equation is ada jauh lah slide tu, malas nak pergi. Equation 2. Sophia is telling us equation 2 and Shiki. Okay, what equation is that? I don't remember. Equation 2. Yes. Ush, ada bunyi ayam. What equation is that, guys?
S equal to 1/2.
U plus VT.
Yes.
Okay, let's try it. Ada equation lain tak yang kita boleh pakai? Another one is V squared U squared plus 2AS. Can we use this one? Does it give us the answer? Can we use this one for our X? Displacement.
No.
Tak boleh kan? Because our A is 0. Basically, you get V equals to U back to square 1. So you don't really solve anything. Ada lagi tak equation yang kita boleh pakai untuk S? S equals to UT plus 1/2 AT squared. Is that the right equation? Betul tak? Malas lah nak baca balik slide tu. Korang pun tak ingat lagi Cepatlah hafal. Okay, it's S equals to UT plus 1/2 AT squared. Okay, betul. Kita akan cuba dua-dua S equals to UT plus 1/2 AT squared. Okay, so this is equation number 3. Okay, kita akan try dua-dua tengok dapat ke tak. So 1/2 U is 50 cosine 30. Basically this is the same thing sebab V dengan U sama for X component. Times pula tu. Tambah 50 cosine 30. And the time we already know from our prediction tadi. Kind of shortcut. 5.1. Okay, can someone calculate this for me? This one. So what's the answer? So yang ni 2, tak boleh buang dah. 50 cosine 30 times 5.1. 50 times 50 cosine 30. So I get 220.84. Sama tak? 220.8.
Sama.
Sama. So let's try this one. So why did I use 50 cosine 30 and not 50 sine 30? Why? Kenapa saya pakai 50 cosine 30?
R is maximum of
Tak dengar tadi. Calculate range use X. Betul. Sebab nak X component X. Okay, betul. Because we're finding range is the X displacement. So we are only concerned about the X component lah. So this becomes, the S becomes X ataupun R in this case. Okay, X ataupun R. And the T becomes capital T. Okay, ataupun I can say X and this is T, boleh juga. Okay, but let's keep it to be T, capital T and R. So the R is 220.84. Okay, sama juga S equals to UT plus 1 over 2 AT squared. We are concerned about the displacement in the X. Therefore, our components yang dipakai dalam equation ni pun kena X components. And the X component of A is 0. So that is our shortcut there. We only have S equals to UT. And U in the X direction is 50 cosine 30. And the time is 5.1. All right, so this gives us our R because this is T. So 50 cosine 30 times 5.1 should get the same answer lah. So yang ni dah buang tadi, 50 cosine 30 times 5.1 juga. Saya tak tahu lah kenapa anak saya buat bunyi macam zombie. Maafkan saya. Okay, so you get the same answer. You can use whatever equations that works. Okay, you're not restricted as long as you know how to use it. Okay. So find the time of flight. We found it, T, range, and then final velocity at the landing point. Okay. So final velocity at the landing point. So obviously we can't use this guy because this is not the landing point. This is V at the maximum height. So how do we find the final velocity of Y at this point? Anyone wants to try? Boleh tak? Nak teka-teka ke?
Sum
Sum of
VX dengan VY.
okay, betul. It's the sum of Vx and Vy, betul. But how do you find Vy at this point? We need to use an equation. What equation is that? Faham tak soalan saya? You guys understand my question? I'm asking you, how do I find the velocity in the Y direction at this point? What equation should I use? Okay lah, I give you a hint. Let's try for equation 1 lah. Kita try equation 1 dulu. So V equals to U plus AT. Okay, what is the T that I should use here? Is it 2.55 or is it 5.1?
5.1.
5.1. Kenapa? 5.1. Okay. Apa dia?
Total.
Total. Okay, that it is a total time. Therefore, it is also the same place as our final velocity, right? Okay, betul. So we should use 5.1 here. Okay, let me buang ni jap. So V, we are trying to find what is the Vy here. The Uy, we already know, 50 sine 30 plus our minus 9.81, 5.1. Therefore, our Vy is something. Use your calculator. Please try it for me because I am very clumsy with calculators. Minus 9.81 times 5.1. So I get minus 25.03. Did you guys get that?
Yes.
0.3 meter per second. So that's the unit. So I get something in the minus. So minus sebab dia tengah jatuh. So the motion is going downwards. The V component, sorry, the Y component of V is going down. So it should be negative. If you get a positive, salah lah somewhere. Okay. So please double check the signs of your answer. Okay, with that said, we already have our Vy at this point. What is the Vx at this point? Kita ada Vy. What is our Vx? So people are writing in the chat box. So it's minus 25.03. Salah. Okay, what is the Vx at this point, at the final landing point? What is the Vx? Okay, so semua orang malu tak nak guna suara. 50 cosine 30. Aisyah said 50 cosine 30. Yen said same with UX. Betul. Balki said 50 cosine 30. Okay, betul lah jawapan dia 50 cosine 30. Kenapa? Because your velocity in the x direction doesn't ever change. We are neglecting air resistance. So the value is the same. Same. Kat sini pun same. Okay, so Vx at the final position is the same as Ux, 50 cosine 30. So this value still applies. Kat sini pun Vx, kat sini pun Vx, kat sini pun Ux equals to Vx. Okay, so it's everywhere, it's the same value. Okay, now that we know our Ux and our Vx, let me duplicate this slide and remove this. Kita tahu Vx dengan Vy. What is the equation that I should use to find my final velocity? What is the equation? Which linear kinematic should I use? Tenggelap.
Vy plus x.
Vy plus Vx. Okay, tapi Vx is this direction and Vy is this direction. So kita tak boleh add them together. What is the equation that we should use to add them together? Ux equals to Vx.
Magnitude.
Magnitude. Siapa jawab tu? Betul.
Saya.
Siapa? Sebab saya tak nampak nama tau bila korang cakap. Sebab tu saya teka-teka je. Okay, betul. You use the magnitude equation which is Pythagoras. Sorry, saya distracted. Pythagoras theorem punya equation tu. So Vx squared, Vy squared. Tadi saya kasih trick question. Saya tanya which linear kinematic equation kan. So I was lying to you guys. Okay, so you should use the magnitude equation. That was a trick question and you failed. Okay, so use the magnitude equation to find the magnitude. So Vx is apa tadi? 50 cosine 30. Okay, harap ni lepas ni kena trick question tak salah sebab saya dah trick sekali, takkanlah trick 2 kali salah lagi kan. So kita kena berhati-hati lepas ni. So Vy is minus 25.03 square root that. So that is your velocity, your landing velocity ataupun final velocity. Not in the x, not in the y, but it's the whole vector lah. Okay, the complete vector, not in the x, not in the y, but it's complete vector. Dah tambah dua-dua x dengan y ni. And what about the angle? How do we find the angle for this landing velocity?
Tan. Negatif.
Tan negatif.
Theta equals to tan inverse tangent of Vy over Vx. Whatever the value of Vy is, whatever the value of Vx is, put in that. Kalau negatif, letak negatif. Jangan lupa. Okay, whatever that is. Okay, so I think we got this. We know what is how to find range. We understand what is the time at the maximum height. It's only this part. Okay, and our Vy is equal to 0 at the maximum height. Remember, if you're finding the maximum height, the final velocity should be referring to that same point. The time should also be referring to the same point, which is here. When you're talking about range, you're talking about the whole duration. Therefore, it is the time of the whole duration, and you will get the R. This is R, this is T, what else? And this is your final velocity, Vx and Vy. Okay. And if you want to find the maximum height, you can divide the projectile motion into 2 sections where Vy equals to 0 becomes your final velocity. Your h becomes your y displacement. Your t is the time taken to find the maximum height. Okay. Any questions about that one before we take a break? Oh, dah 3:30 dah. Let's take a 7-minute break. Okay, and then continue with another example. Come back at 3:34 p.m. Kalau soalan boleh tanya macam biasa. If not, please take your break. Okay, Amy tanya soalan, doktor tak apa yang kalau theta kat landing tak sama dengan angle of projection. So what we're looking at was in a symmetrical punya problem kan. But sometimes we get a non-symmetrical problem like this guy. So it is important for us to know how to do it in general and jangan bergantung sangat kepada shortcut. Sebab kalau simetri kan banyak shortcut kan. Tapi kita tak nak belajar shortcut lagi. So kita just find out how to find the angle using the conventional way lah. Okay? So nanti kita boleh pakai untuk semua problem nanti. Okay, so our break is over. Let's continue. I hope everyone is back from this short break. So this is an example of non-symmetrical projectile motion. The one that we discussed earlier was a symmetrical projectile motion lah, because we could divide it into two and the time taken to complete the first section is equal to the time taken to complete the second section. And that is not always the case for our projectile motion punya problems. So we have to know how to solve in general so that we can solve it. We can solve for any types of projectile motion lah in the future. Okay, so let's take a look at this one. This one is a non-symmetrical projectile motion whereby this is an airplane. It has a velocity in the x direction. It has a velocity in the x direction, and the velocity is equal to 40. This is the velocity in the x direction, and it does not have a velocity in the y direction. Maksud kat sini, previously kita punya V launching angle kita, we had some angle, right? Therefore, we could say that this launching angle has Vx and also has Vy. But in this case, the launching angle is actually just Vx. There's no Vy. Okay, there's no Vy in this case. Dia punya angle apa? 0 degrees. 0 degrees, which means that there's no Y. So there's only Vx in this situation where Vx is equal to 40. Okay. Okay, Vx is equal to 40. So I just put that in here. Ux is equal to 40 and the Uy is equal to 0. Macam mana saya tahu dia 0? Because it is projected horizontally from a certain height. Projected horizontally maksudnya dia tak bagi pun launching angle dia apa. And dia cakap projected horizontally. Maksudnya dia baling ke depan macam tu je. Dia baling palm macam tu je. So there's only an x component. So even though there's only an x component, projectile motion can still happen because we have acceleration in the y, right? We have negative acceleration, which is gravity, due to gravity. So we still have that y component later on, even though our launching velocity does not have a y component. Okay, so let's take a look at this table now. So the final velocity, what is it? And what is the final velocity in the y? What is the time interval and what is the displacement, which is r? And here you already know that the h, or the maximum height, is 100. Because they've given you in this diagram that the airplane started from 100 and went, this is where it landed. So it landed at 0. And as I told you before, S is equal to delta Y. Kenapa nak saya bising tu? S equals to delta Y and Y final minus Y initial. Y final is this guy, 0. And Y initial is 100. So your S is minus 100. Okay. So if they ask you S for here, SY is minus 100. Or in this case, it's a H minus 100. Okay. Kenapa dia letak H? Because it's the maximum height anyways. Okay, maximum height. Okay. So now let's try to solve for final velocity of X. What is the final velocity of X? Anyone? Should be easy now. What is the final velocity of X in the X direction? So semua orang dah mengantuk dah. Apa dia? Berapa tadi?
40.
40, sorry. Saya tak dengar. 40 Okay, thank you. 40, betul. Yay. So it's 40 because X does not change even though it's non-symmetrical. Sama je. Bayangkan kita punya projectile motion ni start pada sini. Vx here, Vx here, Vx here, Vx here. Saya tak tahu nak cakap macam mana dah. Vx does not ever change. Okay. So but now it's only like halfway saja. So still it's Vx. Kat mana-mana. Sama. Sama dengan initial dia lah. Janganlah pergi ambil daripada initial projectile motion tempat lain. Lepas tu apply kat sini. Dia kena sama dengan initial kat tempat yang for the respective motion. Okay. Don't get it somewhere else. Okay. What about our Vy? What is the equation that we should use to find Vy? Everyone's like drowsy now. Sikit lagi, bear with me. Sikit lagi. Kita ada like around 20 minutes to go. Come on, what is Vy? How do you find Vy? Wake up, wake up. V. V equals to, what is the equation? Tiba-tiba blur. Fourth equation. Sophia said fourth equation. What is the fourth equation? I'm sorry. You guys are keep using the 1, 2, 3. Saya tak ingat. What is the fourth equation? Itulah, dah tahu dah korang blur sebab mengantuk. U squared, V squared equals U squared plus 2AS. Okay, let's try that. So, I think that was Sophia, right? Sikit lagi, jangan tidur lagi. Lepas ni tidur. V squared, U squared plus 2AS. So, you want to find out Vy. You want to find out Vy, okay? You have U, you have A, you have S. Betul, let's try it. Okay, so V is equal to, cemerlang walaupun mengantuk. So Vy tak tahu, Vy squared. U is equal to 0, yeah, because we started with 0, projected horizontally. Plus 2 minus 9.81. And S is your Sy minus 100. When we're talking about Y component, please use all the Y components only. Jangan letak sini Vx, kat sini pakai AY. Jangan semua kena sama X ataupun Y sahaja. Tak boleh tambah-tambah tukar-tukar. Okay, so in this case we are using Y's. So semua Y's. S pun Y. Kan Sy kat sini minus 100. Okay, so let's try to solve it. Whatever that is. 2 times 9.81 times with 100, square root that. So I get 44.29. So Vy is 44.29. So is my answer a positive or a negative here? Is my answer a positive or a negative? 44.29. Okay, negative. Ian is saying it's a negative. What about everyone else? Afriza is saying positive. Okay, Afriza, can you tell me why it should be a positive? Is it because of the equation? Sekejap korang cuba jawab dulu. Why so noisy? Okay. So, ada orang tulis jawapan dah ke? Kenapa positif? Senang kerja Haikal, setuju. Amboi. Negatif Afriza. Afriza says negative, sorry doctor. Okay, so Afriza is saying negative Tapi jawapan kita positif. Where did the negative come from? Sekejap, I'm super distracted right now. Kejap. Okay, so can you? Yeah, I'm so sorry. Okay, go. No. Here you go. Okay, sorry about that. My son was playing games and bising sangat, saya tak boleh nak fokus. Okay, so let's see. Decelerate, falling down sebab dia ke bawah. Okay, but our equation, what from our equation we got a positive. Where did the negative come from? Yes, because Yan Shui ni Felicia kan? Feli kan? Betul tak? Ke saya salah?
Bukan.
Oh bukan, it's just Yan, right? Okay, so Yan lagi satu yang Feli. Okay, betul, because it's a square. Remember, if we square root something, we get a positive negative. Saya cerita dah hari tu, lupa tu. Okay, so when you square something or you square root something, you get the answer as positive and negative. And who decides whether it's positive or negative? Who decides? Manusia ke, komputer ke, siapa yang decide? Negatif ke positif? Manusia kan? I told you last time it was humans who are very smart decide this for ourselves. We see it's going down, therefore we choose, okay, answer dia positive negative. We choose negative 44.29. Okay, don't let the calculator decide our life, okay? So we get Vy equals to minus 44.29 because it's going down, we know that. So this becomes minus 44.29. 0.29 meter per second. Okay, so now we have the final velocity check. Now we want to find out what is the time. What equation should I use? Saya rasa ramai dah lalu ni. Sikit lagi, 15 minutes to go. First, V equals to U plus AT. Okay, let's try it. V equals to U plus AT, X ke Y component? X ke Y component? Saya pun dah mengantuk sebenarnya. V equals to U plus AT. So this was Y component. Okay, so someone is saying Y component. Thank you for answering using a mic. Saya penat lah tengok chat. So Vy, we already know what Vy is. And that is minus 44.29 equals to U. Our U is 0 plus minus 9.81 time. So our time is equal to, please use your calculator, minus 44.29 divided by minus 9.81. So time is 4.51. 4.51. Okay, I have a question. Did you guys get the same answer?
Yes.
Okay.
Yes.
So my question is, if I find using this equation, using another equation in the x direction, would I get the same answer? Would I get the same answer?
Yes.
Yes. Sebab so I get the time 4.51 second, and so how do I find the, what was the question? Is this the same time for x? This is the question. We got it using the y component punya equation kan? Is this the same time for x? Or if it's not, why? Why is it not the same, and why is it the same? That's my question. Penting nak tahu benda-benda ni. It's your concept. Why is it the same time as the y? Does time have an x and y component? Banyaknya chat, saya tak sempat baca.
Time tak ada.
Time tak ada because time is a scalar. So if you get time for the y, it's the same time as the x. So you don't have to like buat kerja dua kali because the position is the same. Betul juga. Sophia said because the position is the same. The x and the y position is the same. Therefore the time is also the same. Sebab kalau tak doktor tak tanya. Betul juga. Okay, so the answer is because it's a scalar. Betul. It doesn't have an x and y component. So the x and the y punya time sama je lah. Okay, you don't have to break it down, blah, blah, blah. Okay, so that is your time. So kita dah solve for 4.51 on this side. Therefore, it's the same for this guy as well. Because we are finding at this point, it's the same point for the x. Okay, so now how do I find the displacement? What equation should I use here? So displacement is r. Kita nak cari x punya direction. So we have to use x component punya values. What equation should I use? S equals to I have t, I have v. Okay, someone is tulis kat chat. S equals to, sorry, 1/2 u plus v times t. Okay, let's try that. U 1/2 u plus v plus t. I think Sophia ni memang suka equation ni. Buat dah 2 kali rasanya. And another one that I want to try is ut plus 1/2 at squared. Okay, I like this equation. Saya pun ada favorite juga. Okay, walaupun saya tak ingat ni nombor berapa. So our A is 0 here. U is 40. Time is 4.51. So I get something S equals to ut lah ataupun R. And in this case, 1/2 u plus v, our u is equal to v. So I have 2 times 40 because 40 plus 40 will cancel out. So I get 40t. This one, 40t. T. T sama kan 4.51. So sama, jawapan dia akan sama. So this is R. 40 times 4.51. I would get 180.4. 180.4 sama. Okay, so this is our R, 180.4. Okay, so how do I find the velocity when touching the ground? Okay, ni dah straightforward punya soalan. Ni kalau tak tahu jawapan ni saya suruh korang rotan diri sendiri sebab saya jauh kan. So what is the answer? What is our final velocity? What is our final velocity? I'm not asking about the x and y component. I'm asking about the final velocity vector. Kalau tak korang hutang rotan diri sendiri R, magnitude. Okay, betul. Okay, ada wakil. So tak payah rotan. So magnitude equation is V equals to Vx squared plus Vy squared. Okay, the same old boring equation, Pythagoras theorem. And then your direction is Vy over Vx. In this case, our Vy is a minus and our Vx is a 40. Therefore, you would get something with an angle below the x-axis. You can try this yourself. So Vy is minus 44.29, right? Let's try it. Divided by Vx. Vx is 40. Okay, inverse tangent of that answer, you get minus 47.9. So this is 47.9 degrees. Jawapan dalam calculator is a minus, indicating that it is below the x-axis, which makes sense because kita punya final is this way, right? Whatever that is lah. Okay, so it's below the x-axis, the imaginary x-axis that we always have to draw ourselves. Okay, with that said, I think I'm going to end class here because semua orang dah lalu dah. So let's continue next class and I hope you have a great rest of the day and take care. Okay, if you have any questions, boleh tanya. If not, bye-bye. Okay, take care.
Thank you, Doctor.
Thank you, Doctor.
Sorry doktor.
Thank you, Doctor.
Saya
Thank you, Doctor.
Thank you, Doctor.
Stop sharing.
Thank you, Doctor.
Thank you, Doctor.
Welcome, bye-bye.